Hello. In astronomy, we have superluminal motion. It comes purely from geometry and the finite travel time of light. So we have to note these two things. This is important for solving the problem. Okay, so we have a jet emitting a pulse of light at A and second a time delta t later at B. An observer sees these pulses at point O. The angle here is theta, and this angle phi is small enough that these two are the same. And the speed is beta c, but we'll use that later. So, question, find the apparent transverse velocity vt along CB as measured by the observer in terms of b and theta. Express your answer as bt is vt over c. So why does it want this? Well, as observers, as human observers, our perception is flawed. So because we're this far away, we might see A as being a little bit closer at C. That's why it wants this velocity. But first we can find some distances. So let OB is D, that means OC is also D by small angle approximation. I'll just say less than 1 degree. BA, what is this distance? Well, that's easy, right? Just V times the change in time. Okay. Let's also find AC. So AC is just cosine theta, right? The component, and then BC is the vertical component, which we will need for the transverse velocity. In regards to time, so let the first pulse be emitted at T1 and the second at T2. So delta T is T2 minus T1, and this is the actual time intervals. However, the problem is, as pointed out here, light has a finite travel time, so it'll still take some time for us to actually see the pulse. Right, that's just due to the speed of light. So we can use primes. So T1 prime. We can define another time interval, right? Delta T prime is T2 prime minus T1 prime. And this is observing and then time interval. So what is T2 prime? T2 prime is just T2 plus the additional time it takes light to travel this distance. So T2 plus d over c, where c is the speed of light. T1 prime, on the other hand, is T1 plus this distance. Sorry, I have to zoom out. From O to A, which is d plus v delta t cosine theta all over c. Okay, so if we subtract these, if we subtract T2 minus T1, what do we get? Well, T2 minus T1 is just delta T. We can write delta T prime as delta T, and then we're left with minus V delta theta, delta time, V times delta T over cosine theta over C. Yes. So that's what the observing time interval sees. What the observer sees, sorry. Now we can solve the problem finally. So transverse velocity, that distance is v delta t sine theta. Our time interval is delta t minus that. So if we divide these, we can theoretically get our answer. But note that it's nice because some of this cancels. So when we divide, we're left with cv sine theta. The bottom is 1 minus, should it? Yes, it should be c minus v cosine theta. This can be simplified further by using this substitution right here as highlighted. So we continue. So beta c sine theta over 1 minus beta cosine theta. And this is our transverse velocity. Phew. All we have to do now is divide by c, which just cancels this part. And we have b sine theta over 1 minus b cosine theta. And that corresponds to answer choice A. Thank you for watching. Please like and subscribe. And also subscribe to my good friend Fema Explorer on YT. If you have any comments or suggestions you would like to make, please put them down in the comment section, and I will see you with more physics and FEMA videos. Bye!